Alright, one more example. This is a little bit more complicated. So in this case, the region is defined by, its boundaries are given by x equal to 1, x equal to 2, say y equal to 4, and the graph of the equation y equals x minus 1. And I'm gonna try and rotate this. Let's see, what should I rotate it around? I'm gonna try to rotate it axis of rotation around x equal to 1. So let me draw that. X, Y, x equal to 1, x equal to 2, y equal to 4, and the axis of rotation, and this is the graph of y equals x minus 1. So that's the region that we have to rotate, and we have to rotate that around x equal to 1. Alright, so this point goes here, this point goes here, and we get a volume that kind of looks like a thick pencil. It's a cylinder from here down to here, and then it kind of tapers down to a point. Okay, so the thing to note here is that this outline of the region is now defined by two equations. It's defined by x equal to 2 from here to here, and y equal to x minus 1 from here to here, and that's going to make a difference. And that's why I'm doing this example, so you can see what happens when the boundary is defined by more than one equation. Okay, so again, here's my variable s along the axis of rotation. So for a fixed value of s, I take a cross section, and now I go from here to the point where the cross section meets the boundary of the original region. So that's my variable r. So the coordinates of this point in the rotational coordinate system are s and r. That's the red rectangle. By the way, if I had chosen a value of s such that my point was here, I would then have to pick that point as where the cross section would meet the region, and that's going to make a difference in a second. Okay, now we also need the coordinates of this point in the original coordinate system. So that's the original coordinate system. So that then is the black rectangle. So this is x and this is y. X is all the way from here to here. Okay, so let's write down the equations relating SR to XY. So S is the same as Y. X, which is here to here, R, which is here to here, X is R plus 1, or R is X minus 1. So R equals X minus 1. And then finally, we need to write down the equations that relate the x and y coordinates of this point. And this is where the complication is. That equation depends on whether this point is on that line or whether it's on that line. So we have to figure out what the coordinates of this point are, because we have to figure out for which ranges of s is the point on this line and for which range of s is the point on this line. Now, since s equals y, for all values of y from here to here, the point is on this line. So let's first figure out what the y coordinate of this point is. At this point, x equals 2, therefore y must equal 2 minus 1, which is 1. So the coordinates of this point are 1, 1, which means for s between 0 and 1, so let me write a pair of equations. So 0 less than equal to s, say less than 1. X and y lie on this line. So y equals x minus 1. And then between 1 and 4, s greater than or equal to 1, less than or equal to 4. We know that, let's see, x equals 2, which is the equation of this line. So that's it. Those are our basic equations, and now we have to deal with the fact that we have two different equations for two ranges of s. Okay, so let's do the volume. Oh, I need the limits of s also. So the limits, since s is y, the limits of s are the limits of y. The smallest y is 0, the largest y is 4. So 0 to 4 pi r square ds. Alright, so now we need r in terms of s, and because we have two different equations for two ranges of s, the equation for r in terms of s is going to be different in both the ranges. So I want to split this integral into 0 to 1 plus 1 to 4. So this is just the range from here to here and then here to here. Okay, so 0 to 1, I now have to deal with this. So let's see, r equals x plus 1, and in this case, so if I move my 1 to the other side, I get y plus 1 equals x. So r, which is x minus 1, becomes y plus 1 minus 1 becomes equal to y, which of course equals s. So between 0 and 1, r equals s, and that means, well, let me write this here. That means the first integral, I'm going to pull the pi out, 0 to 1 is s squared ds. Now let's figure out what it is in this range. So again, the same procedure. R we know is x minus 1 and x equals 2 here. So r is fixed, r is just 1. So the second integral, I pull the pi out, 1 to 4, 1 squared, which is just 1 ds. And that's easy. These integrals are easy to do. It's pi s cubed over 3, 0 to 1, plus pi s 1 to 4. And you can evaluate that and get the volume.